Welcome to the GeekSpeak by the GeekyAnts. This is Rohit Ghodke, working as a senior software engineer in the GeekyAnts. In this session, we are breaking down why BFF is must-have architecture in front-end development, especially when building apps that scales across platforms. Yeah. So let me start with a question that many of us have faced. Have you ever felt that front-end application is doing too much work just to communicate with your backend services? Have you found yourself writing complex and transformation logic, making multiple API calls, and then stitching together the response just to render a simple UI component? Yeah, this is exactly the problem that BFF solves. Imagine having a dedicated layer that truly understands your UI needs and serves what you need exactly how you need. That's the power of BFF, that is backend for front end. The first thing comes is like what is BFF? Okay. So BFF, which is a backend for front end, is a specialized server layer that is between your front end and your backend services. In today's microservice architecture, modern applications often need to integrate with multiple backend services, right? So each have its own API for each backend service. So each one of it has its own API, data format, response structure. Okay. So without BFF, your front end becomes responsible for handling this multiple service calls, handling their different response format, and transforming data to match the UI requirements. So in this process, BFF simplifies this whole thing by providing a single unified API that specifically tailored for your front end needs only. The key difference here is that unlike traditional generic APIs that serve multiple consumers, BFFs are purpose built for particular front end cries. Whether you're using web application, mobile app, desktop client, it doesn't matter. It is used for all these purposes. Think of a BFF as a aggregator that speaks fluent front end while handling all the complex backend communication behind the scenes. The next part is why use BFF, why we need to implement the BFF in our architecture. First, it simplifies the API consumption. Okay, instead of front end dealing with the multiple API formats and structure, BFF provides front end friendly data structures that match your requirement exactly. Okay, so suppose you are using React, so your React components or mobile screens get data in exact shape that they want without any additional processing. Second, it excels at aggregating multiple services. Earlier, we see that there are multiple backend services, and what BFF is just aggregate the data. Picture this in this scenario like your homepage. There's a basic homepage. It needs your user information, your recent orders, product recommendations, and promotional offers. I'm talking of a practical e-commerce example. Without BFF, that's a 4 different separate API calls. Okay, one for the whole user information, one for the recent orders, one for the product recommendations, and another for the promotional offers. Now with BFF, it becomes one optimized call that returns everything your homepage needs in a single response, and it will be formatted as you like. Third, why we need to use BFF is it significantly reduces the front end logic complexity. All those that data transformations, filtering operations, all complex business logics is that was cluttering your front end code with can be moved to the server side, which is the BFF where it belongs. Okay, this dramatically improves the code functionality, also maintainability, and your components just make more clearer, more focus on their just one responsibility, which is the rendering UI and proper sync between them. The next topic is the benefits. The first we will discuss on the performance and the scalability benefits. From the performance perspective, BFF addresses 3 critical issues. First, it eliminates the data overfetching. We just discussed 2 minutes before giving the example of the e-commerce of the homepage. Okay, so it eliminates the data overfetching. Second is it minimizes the network latency by reducing the number of round trips between the front end and the back end. Okay, Third, it optimizes the payload size for the specific clients. Like your mobile app gets lightweight responses, your web desktop application might receive more detailed data. The scalability benefits are equally impressive for the BFF. BFF enables true team independence. So your front-end developers can iterate on UI UX without waiting for the back-end teams to modify the APIs. This is huge for the development velocity. It's also easier to scale the specific components for your system. If your mobile traffic grows rapidly, you can scale just the mobile BFF without affecting the web or other clients. Finally, it reduces coupling between the systems, making your overall architecture more flexible, more maintainable, and which in overall increase the speed of your development on the front end side. The other point is on the collaboration and the cross platform. So BFF also transforms like how teams collaborate. Front end developers can focus entirely on creating amazing user experiences without getting bogged down in the like complex data wrangling or API formatting or any other backend services issues. So they work with clean, predictable APIs that match their mental model of the application. Now, for the cross platform development, BFF is a game changer. You can create tailored BFFs for each platform, web, mobile, desktop, each optimized for that platform specific needs and constraints. Your mobile BFF might prioritize nor minimal data transfer and offline capabilities as well. This depends on how you want to structure your BFF as well, but your BFF might focus on like rich data for the complex dashboards and all of this thing. Yeah. The other part is like BFF in action, which is like how exactly the workflow will happen between front end BFF and the back end. Let us walk through the practical example only of the e-commerce. Okay, your front end sends a single request to the BFF. So like something like you if you want to get the get user profile and the recent orders, the BFF then communicates with the multiple backend services. It call the user service for the profile data. It will call the order service to get the recent orders or purchases. Or the if you want to check the order status, then the order services. Maybe you want to call the notification service for the unread messages within the e-commerce. Okay, so here where the magic happens. BFF aggregates all this data, transform it to match your front end expected format, filter out all the unnecessary information, and returns a clean, maintainable, optimized response that your front end can easily use, and it will be no issues in that. Then BFFs are like commonly built with the Node.js for the JavaScript heavy front ends. GraphQL is a very good option for the flexible querying or serverless frameworks like AWS Lambda for cost-effective scalings. This is the real world use case of the e-commerce. In this traditional setups, like when the user visits a product page, your front end might need to make a call to the user service for authentication, product service for product details, inventory service to check the stock levels of that product which the user is viewing, then the review service to get the all the customer reviews, recommendation service to get the related products. This all this functionality we see in our day-to-day e-commerce platforms like Flipkart, Amazon, and all that stuff. Okay, so to get all this details, we need to at least call minimum 5 separate APIs, and each API will add the latency and complexity to your front end code, because we need to handle all the structuring, pre-processing, filtering, all that. Now in this use case, BFF, this becomes a single optimized for. So the performance improvement is dramatic. Like typically you can increase up to 30 to 40% faster load times because you have eliminated four network round trips, 4 or 5 to API called round trips. Your front end code becomes significantly cleaner because there is no data merging, mapping, conditional logic, filtering, processing, any other cluttering your components. So your components will have clean UI for the user experience, whatever the CSS, and just be this API integration. Yeah. The reusability factor is huge. The same BFF logic supports both your web and mobile applications. So as BFF is not attached to any kind of technology or any kind of platform, it is more, you can say, standardized. You can use in both mobile, web, or any other uh, client as well. From a security perspective, your BFF can sanitize data, enrich responses with computed fields, or we can hide information before it reaches the client as well. Okay, so perhaps most importantly, it gives your front end team autonomy. They own their BFF, which means they can iterate faster without being blocked by backend teams who are working on the other priorities as well. These are the other real world use cases. So as the BFF patterns are like getting successful across many industries, news applications use different BFFs for mobile and web, optimizing content delivery for each platform, unique layout, performance requirements, all this stuff. Okay. The other fintech dashboards are the another perfect use cases for the BFF, where the BFFs aggregates data across multiple financial services for the users, like account balances, transaction history, investment portfolios, market data, presenting a unified user view with a platform specific optimizations. And there are many more real world use cases where the BFF can be implemented, and we are also using heavily in our projects. So before going to the conclusions, as every coin has two sides, so there are must be also challenges and trade-offs while doing the BFF, and I would be the transparent on the BFF part as well. First, yeah, there is a complexity overhead. So not a bad complexity, good complexity. So you are essentially adding another layer to your architecture, which means more services to maintain, monitor, and debug. So this can increase operational complexity, especially in the early stages of implementation. Second, there is a potential of code duplication. Like if you are building separate BFFs for web, mobile, desktop, you might find yourself duplicating the business logic as well across all these BFF services. So this requires careful design to extract shared logic into the common libraries or services. Okay. Third, you are creating a potential single point of failure. Like if your BFF goes down, it affects all your front end clients, right? So this means you need a robust monitoring, error handling, and possibly redundancy strategies to fix this. Fourth is like there are performance consideration. Like while BFF generally improves performance, if we design poorly architecture of BFF, okay, that can becomes a bottleneck. So if you are not careful about caching, database queries, or service calls, you might end up getting a slower response than the direct API call. So we need to design the BFFs very properly and very accurately. Fifth, it can lead tight coupling between the front end and the BFF teams. Since BFF is closely aligned with the front end teams, changes in the UI often require changes in the BFF. Okay, but I think this is not major trade-off for this one. But yeah, you can consider, yeah, there might be coupling between the front end and the BFF team. And the final is there is a resource investment. You need developers who understand both front end and the back end development. You also need to need additional infrastructure monitoring, because you need to this deploy this BFF as well. Okay, and BFF is generally the backend part only, which we need to evaluate and give the response. The last thing is the conclusion part. So there is no doubt, like the BFF represents a powerful architecture pattern that address real challenges in the modern front-end development. It simplifies the front-end code by moving complex data logic on the server side, that is BFF. It improves the performance through optimize and the tailored API structuring and for responses as well. And it enhances team collaboration by allowing front end and the back end team to work more independently. And this independent working can increase the performance of the front end team and back end team as well. While there are legitimate challenges to consider, operational complexity, potential duplication, and more resource requirements, these are the trade offs and challenges. while building the BFF. And but at the last, BFF has proven to be the essential pattern. And the question isn't like where the BFF is perfect, or it solves more problems than it creates to be a specific context in your particular application, in your particular scenario. If the BFF suits more properly, just go with the BFF for sure. Okay. And if there is like very small application you need to develop, there are not much more complexity, then yeah, we can avoid the BFF layer for sure. And in the most, like in the modern architectures, like dealing with the microservices and the multiple client platforms, I think the answer should be the resounding yes for the BFF. And I think yeah, that's pretty much for today. And thank you for your attention. Like, I'm happy to take any questions about implementing like BFF in your projects. If you have any doubts, uh, like please drop a comment. And thanks for watching the episode of the GeekSpeak. If you found this helpful, hit like, subscribe, and drop a comment. See you in the next one.